Okay, problem 36 is asking us to find the minimum and the maximum value of this function right here on the interval here from 0 to 2 in this problem. So there's a fundamental idea you guys need to know here, it's in your notes, that an extreme value, like a max or a min, can only occur at two places. That would be critical points and endpoints. All right, and because, now let's see, this is a polynomial function, guys, with an unlimited domain, but they limited that domain artificially for us here, 0 to 2. So we've got our two endpoints. We've got to look for critical points, although it's not a very big range in which to find it, so we might have to throw some out. Let's see what we got here, guys. The derivative of y with respect to x would equal, just using some power rule here, 3x squared minus a 24x and a plus 21. We would want to know, where is that derivative ever equal to 0 or undefined? Well, a quadratic function is never undefined, so we just have to worry about it equaling 0. And I would try factoring this thing before I run to my calculator. Let's pull a 3 out. We're going to get an x squared minus 8x plus 7. And let's see here, guys. I'm pretty sure that one's going to factor by reverse FOIL. That would be an x and an x. Signs would be the same and both negative. Two numbers that multiply to 7. Add up to -8 would be a -1 and a -7. So that one did factor. There's going to be no solution, or no root, I should say, we get from 3. Here, we would get x is equal to 1, and here we would get x equals 7. But much as I thought might be the case, we are only interested in x values here between 0 and 2, so we've got to throw out that x equals 7. And what I'm going to say this carefully, x equals 1 is the only critical point we found within this range of values right here. There is another one, but it's outside the range, so we don't have to worry about it. Okay, so what we're going to do now, guys, let's see, this, oh, that was terrible. Wow, okay. We're going to evaluate this function here, y, at all three values that we came up with right here, the two endpoints, and then also this one critical point of 1. So let's see if I can fit all this in here, guys. And I like to do them in order from left to right. My left endpoint was 0. My critical point, the only one we came up with, was 1, and our right endpoint here is 2. So there's no rule that says you have to do these three in order from least to greatest, just my personal preference. So plugging a 0 into this function, that one I got, just came up with 0. Now at this point, you have no way of knowing if that 0 we just found is a maximum or a minimum or neither, because it's all about the value of that number in comparison to the other two that we're about to come up with. So let's dive in and find out what happens when we put in a 1. We've got a 1, minus 12, and a plus 21. So that would be -11 plus 21 is going to get us a 10. All right. And then let's see if we can plug a 2 in there. That one might be a little bit tougher. That 2 cubed is going to be an 8. Sorry, writing my work over here. And then minus, that'd be 12 times 4, which would be 48, and then plus 21 times 2 would be 42. So we end up with, let's see, that's a 50 minus 48, we end up with a 2. So now, guys, in looking at those three y values that we just came up with, hopefully it's easy to see which one is the max and which one is the min. That 10 that we got right there is going to be our absolute maximum value on this interval, and that 0 is going to end up being the absolute minimum. Now, they did not ask for this, but if we talk about what's going on with this last value right over here too, it's not the absolute max and the absolute min. Remember, guys, when they don't put an adjective in front of max or min in the directions, they are asking for an absolute max or min. And that's what we found right here. Then what's going on at the point 2, 2? Well, if we think about what happened here, we started at 0, 0. I'm just randomly drawing a graph. We went up here to the point 1, 10, and then we came downwards. That's a polynomial, so I guess it's smooth. And then we came downward to the point 2, 2. Not quite as low as where we started. This point right here isn't the lowest point overall, but it's lower than everything else in its neighborhood. So what we are dealing with right here is a relative minimum. Now again, they didn't ask for that, so these are your answers here, guys. Your maximum value is 10, your minimum value is 0, but just if you were looking to go the extra mile, we have a relative minimum value here of 2 that occurs at x equals 2. And that's 36.